another session being organized by NPTEL, where so basically, let me introduce myself first. So I am Shobik. So I am currently a PhD scholar at IIT Bombay, the Department of Electrical Engineering. So basically, NPTEL has started this new session of doubt clearing classes, where basically we will be taking up assignments of the course you are where you are enrolled of the previous year. So basically, since you are all enrolled to power system analysis EE120, so we will be solving the assignments of the exactly of the previous year, so that it may help you in solving the current assignments. So like if you have any doubt, so you can just raise your hand, I'll unmute you. So we'll be going one by one, and especially we'll be looking at very specific questions. So since this is a 1 hour duration, so we won't be having sufficient time to go through all the questions. So if I have made myself clear, so let us start this session. So people are still coming in. Uh, so let me just share my screen. Uh, so if my screen is visible, so if someone can just raise their hand so that I am able to know. So there is a raise hand option. So if you could just raise your hand and let me know that. Okay, fine, fine. Thank you, thank you. Let me just admit all of you. Okay. Uh, so basically, so this is the assignment one, which of the previous year. So you can see this is of 2021. So this is similar to the, I mean, the problem set is very similar to what you have got. And if I am not wrong, the submission date is on 10th August. So still people are coming in. Let me just admit. Yeah. So So basically here, so this is another PDF where I have just solved the questions, and I'll take you through each of them. So let me first go to a special question. So let us go to question number 8. So I hope that people are coming in. Yeah. So I hope that you are well equipped with these terms like coincidence factor, then uh, demand factor, load factor, all these terms. So like we'll walk through the questions. One more help I need. So if you just could raise hand and say whether you are able to see the questions. Suppose, for example, question number 8. Can you see what is written on the screen clearly? You could just raise your hand. Okay. Okay. Thank you. Thank you. So people are still coming. So guys, please join sharp at 7 so that we can start, because already, as I see, we have lost 5 minutes. So you can unraise your hand. Yeah. Thank you. So let's solve this question number 8 together. So as it says that the power station, people are still coming in. So if you could join sharp at 7, it would be very helpful. Otherwise, we'll lose time. And so that, I mean, if you join fast, we'll be able to solve more questions. So anyways, so let's go to question number 8. So as it says that the power station, there's a power station which has to meet the following load demand. So this is load A. So still people are coming in. So so this is the load A, which is active from 8 a.m. to 6 p.m. Then there is this load B, which is of 100 kilowatts, so which is active from 6 a.m. to 10 a.m. And then there is this load C. Let's keep coming in. Yeah. And then there is load D, which is like operational in 2 time periods. So 10 a.m. to 6 p.m. and 6 p.m. to 6 a.m. So now here we have been told to calculate the coincidence factor. So for calculating the coincidence factor, I mean there is another way of solving this problem. So we could just calculate the diversity factor, and so coincidence factor is just the reciprocal of diversity factor. So now here, so the approach of solving this problem is to create a table. So I mean this load table where here this row has all the time period, so you can, so what I have done, I have divided the time periods into this set. So it is, so first is from 12 a.m. to 2 a.m., then 2 a.m. to 4 a.m., then 4 to 6, and so on till midnight 12. So now here we have to just write, I mean in each of these cells or columns, whatever you call, so we have to just write. People are still coming in. So guys, please try to join sharp at 7 so that we can start ASAP and not lose time. So as I was saying, so in each of this table, so you have to write or fill up this table as per the load. So for example, as you can see, so load B is active from 10 a.m. to 6 p.m. So 10 a.m. so 10 to 12 the load is active, then 12 to 14 then active. So this continues till 6 p.m. So 6 is, so 16, so 4 p.m. to 6 p.m. So until here. So after that, again if you see, um, so again it is active from 6 p.m. to 6 a.m., so another 12 hours. So you then again keep on filling this. So from 6 p.m. till you do this till 6 a.m. in the morning. So this you have completed for load C. Now if you sorry, load D. Now if you see load C, so it is active from 8 a.m. to 12 p.m. So basically 12 in the noon. So just you can fill it here. So from 8 to 10 it is 50, then 10 to 12 it is again 50. So you have completed for C and D. Now load B is active from 6 a.m. to 10 a.m. So you can fill it here. So 10 a.m. so this 100, and then again this 100, and similarly load A from 8 a.m. to 6 p.m. So you can do fill it in this fashion. So after this, what you do is that you calculate the total load. So total load means total load, let's say, which is active from, I mean, in each duration. So if you see from 12 a.m. to, so people are still coming in. So um, from 12 a.m. to 2 a.m. So this is 80. I mean, in this way you can sum it up. So for each, what I can say, for each column you can sum it up. And now from this table you can see that the maximum demand is 350 kilowatt, because from 8 a.m. to 10 a.m. the power plant had the maximum load demand. So it is coming as 350. Now as we know, or if you I mean know, if you see the formula of diversity factor, so it is the sum of individual maximum demands. So maximum demand means the total load demand at the power station, total maximum load demand at the power station, divided by the system maximum demand. So the total maximum load demands are the sum or the summation of these four loads, which is 200, then 100, 50, and 80. So you just take the calculate the sum of these these four loads and the system maximum demand. So the maximum demand at the power station is between 8 a.m. to 10 a.m. So it is 350. So I mean, as per the formula, so the system demand is 350. So here, from here you can calculate the diversity factor, which is coming out to be 1.2286. So now the coincidence factor is just the reciprocal of the diversity factor, so it is coming out to be 0.814. So which is option C. So this is how, I mean, you can solve this problem. So now, yeah, so like as I told, so after every question I'll ask whether if there is any doubt or not. So I mean, if there is any doubt, you can just raise your hand. I'll unmute you and let you speak. So for raising, okay, let me unmute you. uh your hand was you just deactivated your raise hand. So like if anyone has any doubt, he or she can raise her hand. I'll let you speak. So like I'll wait for 1 minute. So if there is no raise hand, I'll assume that you all have understood this question and how to solve it. So let me again take you through this question. Achha, okay, there was a raise hand. Yeah. Okay. So yeah, Durvesh, you can speak. I hope I have allowed the mic.
Yes, sir. Yes, sir.
Yeah,
Sir,
yeah,
the load of maximum individual demands means we have to take the maximum demand of individual. Now, for example, in load C, the all
yeah.
were 80s. No, all load were 80 watts.
Load
So if
D,
there
right?
is load D, sorry,
Yeah,
load D.
yeah, yeah, yeah.
All load D were 80 kilowatts. If there is 90, so we have to consider 99 maximum individual
So I mean, if I got
for
your
diversity
question.
factor to find diversity factor.
Yeah, so as you can see in the question, so load D is 80 kilowatt. Yeah, if it is 90 kilowatt, then you have to take 90, right? And then find the maximum demand at each time interval. Yeah.
Yes, sir. Thank you, sir.
Okay, okay. Welcome. So, Durvesh, you can unraise your hand. Thank you. So then let us proceed to the next question. So as I told you, so I am picking up some typically good questions I got in the assignment, and let us go on solving that. After that, if time permits, we can look at other easy questions. So yeah, so that is how we'll proceed. So let us look at this question number 9. So as it says that the peak load on a 50 megawatt power station is 35 megawatt. So it supplies to 4 transformers whose connected loads are these are the connected loads of 15, 12, 8 and 10 megawatt. So the maximum demands on these transformers. So just I mean look at the sentence. So it supplies through 4 transformers whose connected loads are 15, 12, 8 and 10. So the maximum demand on these transformers, these are 13, 10, 7 and 9. So here they have mentioned the annual load factor, then the plant, and then the plant operation factor. So the plant capacity factor, you can say. So it is 60% period in the year. So from here we have to determine the demand factor and the diversity factor. So just for all of your convenience, so I have drawn a single line diagram here. So here basically there is a power station which is feeding power to this feeder, which is connected to these 4 transformers. So these 4 transformers are feeding 4 loads. Now, so the again this so this is how we go on solving this problem. So the station rating is 50 megawatt and the its peak load is 35 megawatt. Now these are the loads that the transformer is powering, and these are the maximum peak demand of these loads. Now this is pretty simple. So the demand factor, or DF, is the maximum system demand divided by the total connected load. Now so as you can see, the uh, power station is rated for 50 megawatt. So the its connected load is 50, and then for the 4 transformers, these are the connected loads of 15, 12, 8 and 10, and the maximum system demand for the 4 transformers are this, and the maximum demand for the or the peak load, which is both the same ways, so it is 35. So you just perform this simple mathematical operation, so you get 0.778 or 779. Now comes the diversity factor. So basically here there is a, I mean there is a slight what I can say, I mean you can slightly get confused here. So as we saw in the previous problem, so the diversity factor, it is the sum of the individual maximum demands of the so for this problem it is the transformers, because the basically there are 4 loads and these 4 loads are connected to 4 transformers. So basically the sum of the individual maximum demands of the transformer divided by the maximum demand of the that the power station is receiving. So which is 35, and we also have these maximum demands of the 4 loads, which is 13, 7, 10 and 9. So you perform this, calculate this, so this comes out to be 39, 35. So you get 1.114. So this is how we go about solving this problem. Now again, like if anyone has any doubt. Okay, so I see raised hand. Okay, so wait, let me allow you to speak. Yeah, wait. So Mr. Equimber Shah, you can speak now.
I'm not audible, sir.
Yeah, you're audible. Yeah. Hello. Yeah, you are audible. You just need to unmute and speak.
Not audible, sir. आवाज नहीं आ रही है, sir.
Uh, you can't hear me? I can hear you. Hello. Hello. Uh, if someone else can, I mean, others can hear me, can they raise their hand, please? Okay. Okay, fine. So those who could hear me, could you
Sir,
just
आवाज नहीं आ रही है, sir.
आवाज बाकी लोग को आ रहा है, मुझे पता नहीं, मतलब बाकी लोग ने हैंड रेज किया तो others can hear me, I guess. So okay, so let me unmute others. So maybe you can try later. So Mr. Avinash, I have unmuted you. You can speak now.
Sir, your screen is not changed.
Yeah. Now you can see, right? The question. Hello.
I have only see your load problems and
No. Yeah, you can see the PDF, right?
yes,
So do you have any doubt in that? So that is, I mean, in this question,
mm, means in a load problem.
which problem? Question 9 or the previous one?
9 sir.
हाँ बोलो क्या डाउट है?
So स्लाइड ही चेंज नहीं हुई तुम्हारी इसमें तो
स्लाइड नहीं है, ये पीडीएफ है. सो पीडीएफ तो नीचे जा रहा है ना.
नहीं सर, वो दिखा नहीं रहा, स्टॉप दिखा रहा है इस पे मोबाइल पे.
अच्छा रुको लेट मी शेयर माय स्क्रीन अगेन. रुको, पता नहीं चलता. अभी दिख रहा है क्या? एक मिनट, अभी दिख रहा है क्या स्क्रीन?
यस दिखा.
हाँ मतलब मैं स्क्रॉल कर रहा हूँ. यू कैन ऑल्सो सी दैट, राइट?
यस सर.
तो आई मीन डाउट कहाँ पे था? वेयर वाज योर डाउट दिस प्रॉब्लम?
क्वेश्चन ही दिखा नहीं सर, तो डाउट कैसे?
अच्छा, क्वेश्चन नहीं दिखा. ओके, तो
हाँ,
अभी
सर.
दिख रहा है क्या क्वेश्चन? हेलो,
Yes, sir.
तुम्हारा आवाज ब्रेक हो रहा है थोड़ा. क्वेश्चन दिख रहा है क्या? क्वेश्चन नंबर 9 दिख रहा है क्या? हेलो. So if anyone else has any doubt, you can raise your hand. I'll पता नहीं उसका क्या issue है. I'm not able to figure out. You can raise your hand if you have any doubt, or if you have not able to see the question, we can go through it again. So just raise your hand, like if you have not properly seen the question. So Akvimber, I have unmuted you. So can you speak now?
यस सर.
Yeah.
लास्ट टाइम ऑडियो आवाज ही नहीं आ रही थी सर.
पता नहीं यार, तुमको ही नहीं आ रहा था शायद, बाकी को आ रहा था. तो
नहीं सर, अब आ रहा है सर. अब हमने.
अब आ रहा है ना?
हाँ सर.
हाँ, तो क्वेश्चन 9, did you go through this? I mean, were you able to understand, or should I go again, repeat again?
रिपीट अगेन सर प्लीज.
ओके ठीक है, अनम्यूट करो फिर. Yeah, okay, thanks. So basically, the has a capacity of 50 megawatt. So there is, I mean, it has a peak load of 35 megawatt. Now it supplies through 4 transformers, which I have drawn here: T1, T2, T3, T4. So it supplies, so these are connected to 4 loads: L1, L2, L3, L4, whose rating are, so load rating is these 15, 12, 8 and 10. Now each of these 4 loads, these have, I mean the maximum demand, or rather not 4 loads, so the maximum demand on these 4 transformers are 13, 10, 7 and 9. Now इन्होंने क्या पूछा, they are telling us to determine the demand factor and the diversity factor. So also other informations that are given are, so the annual load factor is 0.5%, 50% or 0.5, or the plant is operating for 60% period in the year. मतलब plant use factor is 0.6. Now demand factor. So they have asked us to determine the demand factor. So the demand factor is the maximum. I mean, if you go through the formula, if you know the formula, so it is the maximum system demand divided by the total connected loads. So the maximum system demand. Now system demands includes the transformers, the 4 transformers which are connected to these 4 loads, as well as the 4 I mean the power station. So the maximum demand of each of these 5 components are mentioned here. So they are, so for the power station it is 35, then for these 4 transformers they are 13, 10, 7 and 9. So ये हो गया ये, so this is 13 plus 7 plus 9 plus 35, and the total connected load. So the power station has a rating of 50 megawatt, and the 4, I mean the capacity of these 4 transformers, or you can say the total loads that are connected, not the capacity, sorry. So the total loads that are connected to these 4 transformers, they are 15, 12, 8 and 10. So you can do just this simple addition and then divide it, so it comes out to be 0.779. Now उसके बाद क्या पूछा, diversity factor. Now again, as we saw in the previous problem, so the diversity factor is defined by the sum of the individual maximum demands of the different loads or the different components divided by the total maximum demand. अभी इधर maximum demand मतलब power station है, तो we have to consider the maximum demand of the power station, which is, we know it is 35, and the individual maximum demands of the transformers are 13, 10, 7 and 9. So if we do this, so it comes out to be 39, so you get 1.114. So this is option A. So this is how you solve this problem. Now let me go back and see if there are any doubts. So again, if there are any doubts, you can just raise your hand. So Akwimbat, abhi, you got this problem, right? I hope.
Yes, sir.
Okay, okay, fine, fine. Okay. I hope it is the same for others as well. If you have any kind of doubt, I mean, whether if you are not able to see the screen or you are not able to hear my voice, so you just raise hand, I'll unmute you and let you speak. Now, I hope there is no raise hand. Okay, thank you. So now let us go to question number 10. So question number 10 में क्या बोल रहा है? It has been desired to install a diesel power station. So let me just zoom into the question. Yeah, so that all of you can see. I hope all of you are able to see. Okay. So question number 10 में क्या बोल रहा है? There is it has been desired to install a diesel power station to supply power in a suburban area having the following particulars. So there are 1,000 houses with average connected load of 1.5 kilowatt in each house. So उसका demand factor and diversity factor are 0.4 and 2.5 respectively. Now 10 factories have overall maximum demand of 90 kilowatt. Just okay, so people are still coming in. No, okay. So now point number 2 is so 10 factories have overall maximum demand of 90 kilowatt. Now just look at the sentence carefully. So the overall maximum demand. So okay, we will anyways come to this when we'll be solving the problem. And the third point is 7 tube wells of 7 kilowatt each operating together in the morning. So the diversity among these three type of consumers, or we can say for this whole power station, is 1.2. So they are asking what should be the minimum capacity of the power station. Now let us go through this problem. So as they have mentioned, so there are 1,000 houses with average load of 1.5 kilowatt in each house. So now they have mentioned that the demand factor is 0.4. So as we know that the demand factor is the ratio of maximum demand by total load. Now the the total load would be 1,000 into 1.5, right? Because there are 1,000 houses and each house have 1.5 kilowatt of connected load. So it will be 1,500 kilowatt. Now using this formula, so if we know that the demand factor is 0.4, we know that the total load connected is 1,500. So if we just now we have to just calculate the maximum demand. Now maximum demand of these of these 1,000 houses, they are like if you calculate, so it comes out to be 600 kilowatt. Now they have said that the diversity factor is 2.5. So as we saw in the previous problem, as we saw in the previous problem, the diversity factor is sum of the individual maximum demands divided by the maximum demand of the system. So so from here, the maximum demand that we got is basically the sum of the total maximum demands of all these 1,000 houses, right? So that is why we multiplied it by 1,000 into this 1.5, which we got to be 600 kilowatt. Now therefore basically so from this diversity factor we have to determine what is the maximum demand of the system, so that it could meet the demand of all these 1,000 houses. So you have to just divide 6,000 by 2.5, which comes out to be 240 kilowatt. Now as I was telling, so if you go to point number 2, so that 10, so they have mentioned that 10 factories have overall maximum demand of 90 kilowatt. So this is a overall maximum demand, right? So this is exactly what we calculated for houses, right? So the overall maximum demand we made for houses was 240 kilowatt. Now here they have already mentioned that it is 90 kilowatt. So this is, so the overall demand, maximum demand for factories is 90 kilowatt. And for tube wells they have mentioned, so there are 7 tube wells of 7 kilowatt each. So to determine the maximum demand, you just have to multiply 7 into 7, you get total total demand for tube wells, total maximum demand, which comes out to be 49 kilowatt. Now you just calculate the total sum or the sum of the total maximum demand for each of these three consumers. So just 240 plus 90 plus 49, which comes out to be 379. Now again the diversity factor of these three consumers. So basically these three consumers, or these three loads were being someone is waiting. Yeah. So guys, please try to be sharp. Try to join sharp at 7, because don't try to be so late, please, so that we don't lose time. So where was I? Yeah. So the sum of the total maximum demands of each of these three loads is 379, right? Now if you see, if you go through the look at the formula for diversity factor, so basically, so if I take you back to the previous problem, so where I wrote the formula, so basically it is the sum of the individual maximum demands that the power station has to power divided by the power station maximum demand. So basically, if you just try to think of it, so power station maximum demand would be the minimum capacity of the power station, right? Because it is the maximum demand. So that would be the minimum capacity of the power station. So it is pretty simple. So they have given the diversity factor, which is 1.2. Now you could just divide it, divide 379 by 1.2, you get 316 round about. So it was coming out to be 315 point something. So you can round it up to 316, which comes out to be option number C. So this was the problem number 10. So now if anyone has any doubt or you want me to repeat the problem, you can raise your hand. I'll unmute and let you speak. Okay. Yeah, Durvesh, you can speak now.
So can you please repeat the problem?
Yeah, okay, wait. And one more thing. So so I am recording this video. So like you will get the recording. You'll be able to see the recording. So NPTEL basically will be providing you this recording. So you can go through this again later. I mean, when you wish. So anyways, yeah. So let me again go through. So I mean, it has, so as the problem states that it has been desired to install a diesel power station, so which has to satisfy or meet these three loads. So there are, so first load is, there are total 1,000 houses where there is an average connected load of 1.5 kilowatt in each house. The demand, so for these loads, so all these houses, the demand factor is 0.4 and the diversity factor is 2.5. Now the second load is, there are 10 factories which have an overall maximum demand of 90 kilowatt. And the third load is 7 tube wells of 7 kilowatt each. Now let us, I mean, we have to go through each of these loads. So so there are, if we take the house, so there are total 1,000 houses whose average load is 1.5 kilowatt. So the total load will be 1,500 kilowatt. Now whose demand factor is 0.4. Now demand factor, if you go through the formula, it's maximum demand by total load. Now total load is 1,500 and demand factor is 0.5. So you can calculate the maximum demand. Now maximum demand is basically the sum of the total maximum demand of this 1,000 houses, right? So which comes out to be this 600 kilowatt. Now this diversity, so again they have mentioned the diversity factor of these houses, they are 2.5. Now the maximum demand that has to be met for these houses, it is, I mean, if you go through the diversity factor formula, you will be able to calculate the maximum demand. So it is 240 kilowatt. Now now there are 10 factories having overall maximum demand of 90 kilowatt, right? So this is the, I mean, this is, so the 90 kilowatt is basically the total demand, or the, I mean, the total requirement for this 10 factories. So it is not the individual maximum demand that you have to calculate. So for houses, you multiplied basically 1,000 with 0.5, right? To calculate the total sum of the maximum demand of the houses. But instead, for these 10 factories, they have directly mentioned the overall maximum demand of these houses. So, sorry, factories. So, which is 90 kilowatt. And now there are 7 tube wells of 7 kilowatt. So, just by multiplying, so you'll get it. So, the maximum demand is 49 kilowatt. Now basically these three types of loads, they are being powered by the power station whose diversity factor is 1.2. So these three consumers are these houses and factories and the tube wells. Now the sum of these individual maximum demands of house, factory and tube well comes out to be 240 plus 90 plus 49, which is 379. Now the diversity factor of these three type of consumers is 1.2. Now if you remember the diversity factor formula, so basically in the denominator we had the power station maximum demand. So it is basically so if you just think, so power, what is power station maximum demand? It is basically the minimum capacity of the power station, right? So that just gives the answer to this question. So basically you have to just divide 379 by 1.2, which gives 316. So this is the answer. So I hope I was able to clarify your doubt. Uh, so if you have any further question, you can raise your hand. And again, I'm repeating. So you will be. So I'm recording this video, this session. So you will be able to see or go through all these questions by downloading the video at your ease. So these videos will be provided to you by NPTEL team. So is there any doubt? So if there is any doubt, you can raise your hand. So I'll wait for 1 or 2 minutes, then I'll go to the next question. Okay. Now this is another. So people are still coming in. Yeah. So this is another tricky question which I felt. So let us go through this. Now this is a problem similar to question number 9. So if you see this diagram that I drew here. Now as it says that at the end of a power distribution system, a certain feeder supplies 3 distribution transformers, each one supplying a group of customers whose connected load are as under. So this is transformer 1, this is the load that it is feeding. So it is 10 kilowatt for the first one, 12 for the second and 15 for the third. So these are the demand factors and these are the diversity factors. So diversity of group basically means that there are a group of connected loads. Basically this is the diversity factor for transformer 1, 2.5 for transformer 2 and 1.5 for transformer 3. So basically this is the diagram. So sorry, this will be here. So this transformer will be here. So sorry for that. Now, so that load that is connected to transformer 1, 2 and 3, I have written it like this. So 10, 12 and 15 kilowatt. Now the demand factor or DF is 0.65, 0.6 and 0.7. Now again, as we saw in the previous problem, let me go back. So the demand factor is the ratio of maximum demand by the total load. Now, I mean, you have to just calculate the maximum demand for each of these 3 transformers, right? So you have the total load that is connected and the demand factor. So demand factor is ratio of maximum demand by the total load. So you have to just multiply it. So for first transformer, it comes out to be 6.5. For the second is 7.2, and for the third is 10.5. Now, also they have mentioned key the diversity factor among the transformers is 1.3. So basically for all these, so basically it is the diversity factor of this power station. So it is telling what is the maximum load on the feeder. So problem similar to the previous one actually. So basically we have to find the maximum load that is acting on the power station. Now, so for each of these transformers, we have the diversity factor. So for the the diversity factor of transformer one is 1.5. Now again, please don't get confused by this total maximum demand and maximum demand. So yeah. The total maximum demand of transformer one means that, so let's say transformer one has, let's say, 10 loads connected to T1. So the total demand, total maximum demand means that the total maximum demand of that 10 loads. So you basically you think like you are total basically summing up the maximum demands of each of that 10 loads that is connected to transformer one, which comes out to be 6.5. So similarly for T2 and T3. Now, since we have been given the diversity factor of transformer 1, which is 1.5, so we calculate what is the maximum demand that is acting on transformer 1. So it is not the total maximum demand. It is just the maximum demand on transformer 1. So which you can, I mean, if you see the diversity factor formula, you will be able to, get the maximum demand of each of these three transformers. So for T1, it is 4.33. Then for T2, we all have the diversity factor, which is 2.5. So you can calculate it's 2.88. And for T3, it's 1.4. So, so you divide 10.5 by 1.4, you get 7.5. Now we have the maximum demands of each of these three transformers. So each of these three transformers, these are basically connected to this feeder which is connected to this power station. Now basically we have to calculate the total sum of the total loads or maximum loads that are connected to the feeder or the power station, which is the summation of these three, which comes out to be 14.7 kilowatt. Now we have been given the diversity factor of the feeder or the power station, which is 1.3. So the question is that we have to find out the maximum load on the feeder. So so basically, so again the same formula. So diversity factor is sum of individual maximum loads by maximum feeder load, which comes out to be 11.316 kilowatt, which is option B. So this is how you go about solving this problem. So problem number 10 and 11 were more or less on the same line. So again, if you have any doubt, you can raise your hand. I'll unmute and let you speak. And these problems you can get, I hope you'll be able to get. So these are basically the previous assignment problems. So the problems that were given in the previous course that were run. So in 2021, you can get there. So again, if you have any doubt, you can raise your hand, and let me again say, so you will be able to get or go through this video at your leisure. So NPTEL will be, yeah, okay. I have someone who has raised his hand. Yeah. Yeah, Dhruva, you can
Sir,
speak. Yeah.
sir, can I audible, sir?
Yeah, you're audible.
सर आपने जो भी असाइनमेंट्स किए कि मतलब सिखा रहे सर, वो कहाँ पे सबमिट करना है सर, और कहाँ से आप
सबमिट
हम
नहीं
कलेक्ट कर सकते
करना
हैं?
है, ये सबमिट नहीं करना है, ये
Okay.
बेसिकली लास्ट तुम अभी पावर सिस्टम E120 में यू हैव बीन एनरोल्ड, राइट? तो उसमें
Yes.
इस टाइप का असाइनमेंट्स आता है, ठीक है? तो हर
Okay.
वीक, अभी इस वीक में मैं असाइनमेंट 1 किया, ठीक है? ये जो प्रॉब्लम्स है ये सारा असाइनमेंट 1 का है ऑफ द प्रीवियस ईयर, ठीक है, 2021 का, ठीक है?
Okay, sir.
we have been strictly told that, I mean NPTEL ने बताया हमको, हम लोग को कि we are not allowed to solve the current assignment problems. What we can do is that we can take you through or help you understand the previous assignments का problems. तो वो आप लोग को the current assignments that you have got, it will help you to solve those problems. I hope
Okay, sir.
you got it. Yeah. Thank you. Yeah, Quimber, you can speak.
हेलो।
हाँ, yeah.
हाँ सर, जो अभी आप सॉल्व करा रहे हैं सर, उसका हमको पीडीएफ मिल जाएगा क्या सर? अगर आप पीडीएफ मिल जाता तो बहुत अच्छा।
पीडीएफ, हाँ पीडीएफ भी मिल जाएगा, पीडीएफ भी मिल जाएगा इसका,
ओके सर।
इसका पीडीएफ भी मिल जाएगा. आई होप बिकॉज वी हैव टू अपलोड दिस on a link which NPTEL has provided, and I hope उसमें आप लोग को पीडीएफ मिल जाएगा. और अगर नहीं मिला तो you can write to NPTEL, so I mean they can solve that issue. Okay.
ओके सर।
Okay, thank you. ठीक है, so I hope there are no doubts in this question. ठीक है, और बाकी for example, so this is a very simple problem. So last question number 12. So मैंने assignment 1 जो आप लोग को अभी 10th अगस्त जो कि लास्ट डेट है, डेडलाइन है, उसमें आप लोग को देना है. So I did go through this question, so they were on the similar line. So I hope like if you understand this, you will be able to solve those problems. तो इसमें क्या बता रहा है, ये बहुत ही सिंपल प्रॉब्लम है, वो सिंपल इंटरेस्ट के जैसा. क्या बोल रहे हैं कि इफ द एनुअल लोड ग्रोथ रेट इज 6%, so the growth rate is 6% for an area, so then the demand at the end of 5 years for initial load demand of 100 megawatt will be what? तो बेसिकली ये है इनिशियल डिमांड विच आई हैव रिटन एज P0. सो द रेट ऑफ ग्रोथ इज 6% और द टाइम इज 5 years. So basically the formula for finding the total demand after 5 years is P0 into 1 plus R to the power T. तो ये आप अगर सॉल्व करोगे तो इट कम्स आउट टू बी 133.823 मेगावाट. तो ये बहुत ही एक सिंपल आसान सा क्वेश्चन था. आई होप ये आपको समझ में आ गया होगा. तो आई होप anyways, if you have any doubt you can always raise your hand. Not pertaining to this question, I mean ये जो NPTEL ने शुरू किया, इसके लिए भी अगर आपका कोई क्वेश्चन है, you can raise your hand. Why there is a meeting like this every week. So next week we will be solving assignment 2 together, right? And you people please try to join at 7 p.m. sharp, at 7 p.m. ताकि we don't lose in much time and we are able to go through most of the questions. So अभी मैं अगर पहले क्वेश्चन में जाऊं, I hope there is no raise hand. Okay, fine. So इसमें क्या बोल रहा है कि now we have still 7 minutes left. I hope I'll be able to take you to 3 or more questions. So these are pretty simple questions. Directly you'll put the formula, you'll get the answer. Someone is waiting, I don't know. Okay, someone has raised their hand. Okay, wait, let me unmute. Yeah, Moitri, you can speak.
Hello, hi.
Yeah, hi.
I just had one doubt. In case if I consecutively follow up on the videos provided, in case I'm not able to join the live session, and
Yeah.
then just follow up on the videos that will be provided,
Yeah.
will there be a Q&A session? Because it can happen that maybe after seeing the video, I have doubt in some question.
हाँ.
So will there be some Q&A session at the end after the question?
So basically you have this Q&A. So there is a, I mean, you can post your questions to the NPTEL course page, right? I mean,
Okay.
any question related to the course. So there you can post your questions pertaining to this session. Okay.
Okay.
Usme I can try to solve your doubts.
Okay. Okay.
Yeah. And again, you can always see this video, and I mean, I will also be posting this PDF, so you can go through this PDF. I mean,
Okay.
NPTEL will provide you. Yeah. So we have to upload this recording as well as the PDF.
ओके ओके नहीं मतलब
Yeah.
मेरा डाउट ऐसे था कि सपोज मैं लाइव सेशंस अटेंड नहीं कर पा रही हूँ
हाँ
और
हाँ.
मुझे मे बी 4 या 5 लाइव सेशंस हो गए हैं और मुझे
Okay.
इस करते टाइम अचानक से फर्स्ट लाइव सेशन जो हुआ था उसमें कोई डाउट आता है तो देन
हाँ हाँ, तो आप वहाँ पे मैंने जो बोला ना, जो Q&A पेज है, मतलब कोर्स का, आप वहाँ पे यू कैन पोस्ट योर क्वेश्चंस, सो आई विल बी ट्राइंग टू आंसर टू दैट.
ओके ओके या थैंक्स अ लॉट.
या, वेलकम. So if you have any doubt, guys, you can like, so we can extend the session maybe for 5 minutes, so it's very close to 8. So I mean, आपका अगर कुछ भी डाउट हो pertaining to ये सेशन क्या है, मतलब क्यों करवाया जा रहा है, so I'll answer those questions, not only related to this assignment. And again, please try to join next week sharp at 7. Yeah, wait. Yeah, you can speak.
हम जब नेक्स्ट टाइम करने वाले तो सेकंड वीक का हम करने वाले हैं सर, वो क्वेश्चंस के यही क्वेश्चन पेपर को हम कंटिन्यू करने वाले.
यही क्वेश्चन, मतलब ये देखो, ये असाइनमेंट 1 है ना, तो नेक्स्ट वीक विल बी सॉल्विंग असाइनमेंट 2. ठीक है, यही क्वेश्चन नहीं, ये तो खत्म हो गया. ये जो जितना सारा क्वेश्चन है, ये जो पीडीएफ में है, ये मैं अपलोड कर दूंगा, आप देख पाओगे.
यस सर, वही पूछना था कि नेक्स्ट टाइम हम इसको आगे कंटिन्यू करने वाले हैं या
हाँ
फिर.
हाँ, ये कंटिन्यू होगा. नेक्स्ट टाइम असाइनमेंट 2 करेंगे. मतलब देखो, ये 12 वीक कोर्स है ना, तो ऐसे आप लोग के लिए 12 सेशंस होंगे, लाइव सेशंस होंगे, जहाँ पे आई विल गो थ्रू दिस प्रॉब्लम्स और एंड हेल्प यू टू सॉल्व एंड क्लैरिफाई योर डाउट्स.
यस सर, क्योंकि मैंने अभी वो एग्जाम दे दिया है मैंने, तो मुझे इस सेशन का मुझे कुछ हेल्प नहीं मिली है क्योंकि मैंने वो सेल्फ स्टडी से किया. तो नेक्स्ट टाइम हम वो एग्जाम यानी वो वीक से पहले हमारा ये सेशन हो जाएगा ना सर, जो हमारा ये जो है, तो जो अभी हम कर रहे हैं.
आपका असाइनमेंट 1 का डेडलाइन कब है, मुझे ये बताया. 10 तारीख है ना, मैंने देखा था.
हाँ सर, बट मैंने
तो
अभी वो सबमिट कर दिया है करके.
ओके, सो फाइन, तो वो ठीक है ना, वो तो आपने जल्दी सबमिट कर दिया. हाँ, तो अभी ये फिक्स शेड्यूल है, ठीक है, ये फ्राइडे, नेक्स्ट वीक फ्राइडे को होगा. तो उसमें मतलब अगर आप चाहे इसके बाद आप असाइनमेंट 2 का क्वेश्चन सॉल्व करते हैं, तो तब आपको ये जरूर हेल्प में आएगा.
ओके सर, थैंक यू सो मच.
या, ओके, वेलकम. So I hope I have able to clear all your doubts pertaining to this session, this live session. If you have any doubt, you can raise your hand. Again, कुछ भी सवाल है related to this session, you can raise your hand. Okay, fine. If there are no raised hand, maybe we can solve 2 problems and we'll end the session. और फिर से मैं बोल रहा हूँ, you will be able to access this video and also the PDF. So I'll be uploading both these. So let us go to question number 1. So it is saying ki the load on a 80 megawatt power plant on a typical day or any day is follow. So ये time है 12 a.m. to 6 a.m. The load is 40 kilowatt. Then 6 से 10 बजे सुबह 50 kilowatt. Then 10 से 12 बजे 60. Then 12 to 12 p.m. to 4 p.m. it is 50. Then 4 p.m. to 8 p.m. it is 70. And 8 p.m. to 12 a.m. it is 40. So we have to find out the load factor and the plant factor. So now यहाँ पे you can make this small graph. So initially while solving the problem I actually didn't make this graph because this was pretty straightforward. So later for for the sake of your understanding I made this graph. So basically here on the x-axis we have the time. So basically it is starting from 12 a.m. and ending at 12 a.m. again. So ये 6 सुबह के 6, 10, फिर दोपहर के 12, फिर शाम के 4, 8 बजे ऐसे करते करते it is going on. So from 0 to 6 we have 40, then 50, then 60, then again 50, 70, and lastly we have 40. So in this way you can make this graph. I mean it is just for the sake of your understanding. Now we have to calculate the load factor. Now load factor is the like if you go through or like I have made a formula. I mean I've written the formula, so let me go through this. So as I see, so load factor is basically the ratio of the average load by the peak load. So average load for one day, basically you have to calculate the total energy for one day and divide it by the total duration. So for one day we have 24 hours. So basically you multiply 40 with 6, so 40 into 6, then 50 plus 50 into 4, then 60 into 2, 50 into 4, then 70 into 4, and then 40 into 4. So you get around 1200, which is so this is sorry. So this will be megawatt. So so the unit is the unit of the numerator is 50 megawatt hour, or the total, and the total duration is 24 hours. So you just divide it. So you will get so this will be So this will be 50 megawatt. Now so from this chart or this graph, as you can see, the maximum demand on this power station on this very day is 70 megawatts. So as we can see from this graph, so it is 70 megawatt. Now the load factor, it is the average ratio of average load divided by the this thing, the maximum demand on this very day. So which is 50 by 70. So you calculate, it comes out to be 0.714. And the plant factor, so the plant factor, if I see, so plant factor is basically the actual energy produced, so which we have, which is 1200 megawatt hour, and divided by the plant rating. So the plant rating basically is 80, and since this is energy, and you also have to convert this 80 into energy, so you have to multiply it with time. So which is 1200 by 18 to 24, which comes out to be 0.625. So this was a pretty straightforward problem. So which is your option A. So if I say so, question 2, question 1, 2, and till 5 or 6, these are pretty simple questions. So straightforward, you just have to put the formula. That's it. So if you have any doubt, yeah, okay, I see I raised hand already. Yeah, Dhruva, you can.
सर मुझे एक डाउट था सर कि ये जो असाइनमेंट है और जो ये सबमिट कर चेकआउट क्या करना है सर, मतलब ये असाइनमेंट हम कहाँ चेक कर सकते हैं?
ये असाइनमेंट्स देखो, बेसिकली ये असाइनमेंट्स है प्रीवियस ईयर के, ठीक है। आप लोग जो अभी पावर सिस्टम एनालिसिस में रजिस्टर किए ना, उसमें अभी आप लोग को कुछ असाइनमेंट्स मिल रहा है। ये जो हम लोग असाइनमेंट्स अभी सॉल्व कर रहे हैं ना, ये प्रीवियस ईयर के है, ठीक है।
ओके सर।
तो
नहीं सर,
ये
मुझे ये डाउट था सर कि ये असाइनमेंट जहाँ पे आप अपलोड करने वाले हो वो चेकआउट का मतलब चेक कहाँ करना है, वेबसाइट पे?
वो NPTEL आपको लिंक दे देंगे, ठीक है। वो NPTEल वो मतलब दैट जॉब उसको वो काम है NPTEL का, वो NPTEL
और
आपको
सर
दे
इस साल
देंगे।
के असाइनमेंट कहाँ मिलेंगे?
इस साल के असाइनमेंट्स तो आपको वो कोर्स पेज में असाइनमेंट्स टैब में मिल जाएंगे ना आपको।
ओके सर,
या
थैंक यू सर।
ओके, वेलकम। या Quimber, wait. You can speak. Dhruva, you can unraise your hand.
हाँ यस सर, वो जो असाइनमेंट बोल रहे हैं ना सर, वो एकदम अपने जब अपन सब लेक्चर करते हैं ना सर, उसके लास्ट में ही है सर दिया हुआ। वो असाइनमेंट को क्लिक करने के बाद हम चल जाते हैं सर उसमें।
हाँ हाँ, मैं वही बोला, उसमें वो असाइनमेंट टैब में वो मिल जाएगा, वही मैंने बोला। थैंक यू। तो ठीक है, इट्स ऑलरेडी 8:05, तो ठीक है। दीज सो आपको ये वीडियो भी मिल जाएगा आप लोग को, एंड दिस PDF ऑल्सो। सो बेसिकली ये है पूरा असाइनमेंट क्वेश्चंस। सो मैंने एक्चुअली ये डाउनलोड किया, तो मैं एक्चुअली ये दोनों ही अलोंग विद द वीडियो में अपलोड कर दूंगा। तो इसमें क्वेश्चंस रहेंगे और इसमें आंसर रहेंगे, ठीक है। तो यू कैन गो थ्रू, and I hope this will help you in solving the assignments, current assignments. So again, let me repeat again, please try to join the meeting by sharp 7, ठीक है, ताकि हम लोग मतलब we can solve as much problems as we want, and I'll try to clarify your doubt मेरे से जितना हो पाएगा। या तो हाँ, आज का इतना ही। सो I mean, if you have any doubts, you can ask, and I mean, the session is over. Rest you can leave. If you have any doubts, you just raise your hand. I'll unmute and let you speak. Yeah. हाँ, Aquimber, you can speak.
सॉरी सर, बट हमने ना आपका इंट्रोडक्शन बराबर सुना नहीं है सर, तो सो प्लीज एक बार प्लीज।
क्या क्या समझा नहीं मैं।
हमने सर आपका इंट्रोडक्शन बराबर सुना नहीं है, सो प्लीज सर आप एक बार फिर से
ओके
अपना
ओके
इंट्रोडक्शन दे
ओके।
दीजिए।
So basically, I am a PhD student at IIT Bombay. So basically, I am a PMRF scholar, so Prime Minister's Research Fellowship, जो अभी डॉक्टरल आई मीन फेलोशिप प्रोग्राम स्टार्ट किया है। तो उसमें बेसिकली वी हैव टू टीच in outside institutes, so institutes apart from where we are doing our PhD, that is IIT Bombay. तो उसके लिए बेसिकली इशू क्या हुआ था, वी वर आई मीन अदर IITs like IIT कानपुर, IIT खड़गपुर, PMRF students were having facing difficulty to go and teach outside. तो उसके लिए क्या किया, NPTEL started this program where we as PMRF scholars, we will be taking up a particular course. For example, मैंने ये power system analysis by I mean which is conducted by IIT Kharagpur. तो मैंने ये I registered for this, and my duty is to conduct a live session where I will be going through some of the typical problems of assignment problems of the previous year, ये year का नहीं, because we have been strictly told that we are not allowed to solve the current assignments, क्योंकि वो काम आप लोग का है। because मतलब इसका हेल्प लेके आप लोग अगर वो असाइनमेंट सॉल्व करोगे, then it will help you to score to fetch good marks. तो बस यही है।
ओके ओके, थैंक यू सर, और बेस्ट ऑफ
Yeah.
लक सर आपके PhD के लिए।
Well, thank you. So yeah, if you guys don't have any other question, you are free to leave. So let me also stop sharing my screen, and let me stop recording.